In the last class, we have created this pod manifest file and we have deployed the pod, right? And this is our pod which we deployed. So yeah, this was running and this was doing good. But what if we want to scale the pods? Like I want to run 10 pods, or else I want to expose this pod to the external world, or else I want to implement rolling updates and rollbacks. So to achieve all of this, there comes another advanced object in Kubernetes called deployment object. Deployment is another REST object in Kubernetes API. Right. So if we deploy the pod through deployment object, we can achieve all of this. This is the advanced and the best way of doing it. So what is the difference? What is this deployment object? So you can consider deployment object like a wrapper over your pod. Whenever you create a deployment object, like let's say it is every object will have some name, some labels. You may give some label. Let's say deploy v1 is the label. Whenever you create a deployment object, it will create something called replica set inside, right? And this replica set name will be prefixed with the same deployment object, deploy1 with some suffix. What is the importance of replica set? Replica set is again an object in Kubernetes API, which will make sure it's having the desired number of replicas you have defined in the manifest. Means it will have the pod replicas. Like I told you, right? I want to scale 10 pods. I want to have 10 pods. So whatever be the number, you can configure the number in the manifest file and it can have those many number of pod replicas. All these are replicas means we'll have same configurations and all of them will be coming from the same Docker image or whatever, same image. So yeah, you can scale out or scale down the replicas in this deployment. Like let's say I want to have 10 replicas. I want to scale out or I want to scale in, whatever. All of that can be. This replica set make sure it's having desired number of pods defined in the manifest file. So this is the hierarchy. Whenever you create deployment object, it will create a replica set. Within the replica set, you will have a pods which are all replicas. And this replica set make sure you are having the desired number of replicas. Right? That's the importance of it. If you just deploy the pod, you can't scale them properly. You can't scale them out or scale in properly. Also, the another importance of this is rolling updates and rollbacks. How is rolling updates, rollbacks possible with this deployment? We'll see later one after the other. But this is the first thing you can see. See, you can imagine this like another wrapper, right? Another layer around your pod. So rather than deploying pod directly, always deploy it through deployment object. Okay, how to create a deployment object? Let's see. First, I'm going to delete the existing pod. You can keep it, but just I'm cleaning up because that's not the real way of doing it. That's not the best practice or that's not the production way of deployment. So I'm deleting it. kubectl delete pod. First, always kubectl get, kubectl delete, kubectl create, type of the object and name of the object. Type is pod and the name of the object. So it's deleted. And if you see no pods in this namespace, let's create another manifest file. I'm creating the manifest file as deploy1.yml. So how to create a deployment manifest? Yesterday I have already shown you. Go to Kubernetes official documentation, deployment object in Kubernetes. Okay. Deployments, different use cases. See, rolling out a replica set, new state of pods. You have so many things. Here is the deployment manifest file. You can copy this. This is allowed, like I said, in the certification as well as in the interviews. But of course, you don't need it with the practice, with the hands-on. You can just keep writing yourself. So let's come to each parameter one by one. First one is API version. If you recollect the session yesterday, or if you have gone through the recording, you know this very well. API version, right? API version is nothing but the standard parameter. API version, kind, metadata, specification. These are the standard parameters, I can say, or else fixed, mandatory. API version, kind, metadata, specification, right? Every object will have metadata and specification. This metadata and specification are about deployment object, are for deployment object. Okay, so first let's see this. API version apps v1. Deployment object is available in the advanced version of Kubernetes API, which is this one. Kind is deployment. Name, you give some name. Labels also of your choice, you give something. So metadata. Uh, Information about deployment object. Then specifications. What is inside deployment object? You will have replicas. See, replicas. How many replicas you need, you can put there. Then comes selector match labels. Means this replica set should select the pods with this label. Like what should be the label of the pods within the replica set? Template means a format, because all the replicas follow a format, right? Or like a blueprint, a copy. So this is the template. And here comes again metadata and specification. This is metadata specification of a pod object, right? It's a nested kind of. So again, the label is Nginx. Inside the pod, you have, again, this is yesterday's YAML file. If you check, it was nothing but the yesterday's manifest file. Before this, let me just modify with our values. I just want this to be deploy one. Label is app v1. Okay, replicas are 3 here also. See the label, this label is the label of the pods. App v1. Containers. The name of the container is, let's say, deploy container, deploy v1 container. Okay, and then the image, and the image is username, repository name, deploy colon v1, right? So now, yes, see here, deploy one is the deployment name. Within that, you have a replica set name and the pods as such. And 3 pods will be started. If you change this number, you can increase or decrease it. So first metadata specifications are of deployment object. Inside that again, you have a pod object. This is again a pod manifest file. Understood the manifest file, everyone? Any questions from anyone?
Means first metadata is for the, what we can say, for the entire manifest file, and second is for particular pod.
First one is for, here I have written arrows. See,
Yeah.
first metadata specification are for deployment object.
Yeah, it's for object, and second is for the pod.
Yeah.
Pretty, this DevOps trainer slash deploy colon v1, this v1 is what?
Tag name.
Tag name.
Tag name of the image.
Means image name should be match. Whatever we have in our Docker repository, it should be match here.
Yes.
That.
See, I am assuming you are all have done,
Yes.
you all have done hands-on, you are well versed to it. So
Yes,
I did
yes,
not
yes.
show that.
Yeah. And if suppose here is it didn't match anything in our repository, then what will be the scenario, Preeti?
If it doesn't,
If it's the doesn't match with the name in repository,
it
what
will
will?
throw error. The image is not there as such.
Okay.
It will throw an error. Okay, V2 is here. I'm removing others. This is
It is at the bottom.
V1, V2. Any more questions? Now this is the name. Got it? This is my image in Docker Hub. If any incorrect, if the image is not there, it will throw an error. Or else if it's in private repository, it will throw an error. It is in public, so I'm not giving any credentials and directly doing this. Can I apply?
Yes.
Before that, I will show you one more thing. Now compare. See, this metadata specification, same as this one, right? See here, containers, name, image, ports. Earlier we deployed this part directly, but now this is being wrapped around another layer called deployment and we are deploying it. Making sense now? Exactly same. If you want, you can also put name here. Name labels are optional and as per your interest. Of course, we don't put name because they're all replicas, right? So got it now? Can I clear the screen?
Yes.
Okay, now let us apply the manifest file kubectl apply -f. Command is same, whether you create pod object or deploy object, whatever it is, apply or create. For the first time, you can do create. Later on, if you are modifying it, you can do apply. But for the first time also, you can apply. Anything is fine. Okay. So it says deployment object created. How do you see deployment? Any object in Kubernetes. Remember, any object. Kubectl get deployed. See, 3 by 3 means 3 replicas were ready. Like I told you, inside the deployment, you'll get a replica set, get RS. See, I told you, replica set name will be suffixed. Sorry, will be prefixed with the deployment name and some other suffix. Right? See, deploy one, inside it replica set, inside that you get a pods. I want to see all the details with output wide. So see, pod is prefixed with a replica set name. Do you see that? 6986 replica set name. This is all replica set name. That's a hierarchy. They were all running different IPs for the pods within the range of a CIDR IP address range you have given yesterday. And they're all running on worker node 1 because I have only one worker. Great, right? So, and if you want to see more details, you can describe any object. Describe deploy. What is the deployment object name? Deploy one. Okay, it can show you the name, the labels, everything. And see, replication controller. I told you, right? There are replication different controllers which will deploy. Scale the pod to 3. You can describe the pod, you can describe the replica set, everything. When you describe deployment, it will show you which image it is running. This image it was running. You can describe a single pod, or if you don't put the name, it will show you all the 3 pods information. See, 3 pod information. And they're all having which label? This label. So if you want to see how many, I'll describe the pod. It's huge output. Out of that, I would grab this label. How many times this label will be there? 3 times in the describe. 3, 4. And see here, every time successfully assigned it to worker node. Kubelet pulled the image. Kubelet started the container. This is important for troubleshooting, describing everything. And also, pods are running. If something goes wrong or if you want to check, you can check the logs, kubectl logs of the pod. Of course, here there's nothing. Otherwise, you should see some output. Kubectl logs and the pod name. That's how you check the logs. Any questions? Oh, yeah, we have 3 now, right? What if I want to increase the number or I want to decrease? Just change the number and apply the manifest file. Let's see that as well.
Preeti, here, what is the last column? Readiness gates.
Where is this?
Last column, yeah.
Readiness is, you can set some readiness to your container, like whether the container is ready or not, like health checks. When the container is configured, the container should be made with the health checks. So if such things are configured, you will see them here.
Okay.
And for logs, see, it was showing this one because this is the port that should be open where you check the logs of the pods. And what is this 30.86? Which node is it? This is the worker node. Just open those ports 10 to 50. You can remember these ports. Actually, if you create a cluster on a cloud, you don't see all of that. That's the reason you should first do it here. Okay, now let me check this. See, it doesn't give that it could not connect, but there were no logs for this pod, that's all. Right? So 10.0.250 should be open on all worker nodes, even on the master node also. All right, that's how you check the logs. Now, what if I want to increase or decrease the number? Go and edit this file to the number you want. Let's say I want to scale down to 2. Then apply the manifest file. Create will not take because already object is there, see? So from the second time onwards, you should use apply. For the first time also, you can use apply, but create you cannot use second time. So it says configurations are applied. Now let's see the pods. First, let me show you the kubectl get deploy first. See 2 replica set is also same. See here within the replica set, get pods, only 2 pods. One got terminated. Now, do you see the hierarchy? Can you relate it to this diagram now, everyone? Deployment within that replica set, within that the pods, the hierarchy. This is very important so that they make sure they are running the desired number of pods and other advantages. We'll see one after the other. Clear with the deployment object, everyone?
Yeah, one query, Preeti, here. When we are scaling in or scaling out, okay, it should be on the fly, right?
On the fly in the sense automatic, you mean?
Yeah, no need to stop the pods.
No need to stop the pods. You just change the number and apply it, right?
Yeah.
This is one thing. You don't need to stop or anything. This is one thing, but whatever we are doing is not automatic scaling. Okay, we are scaling, but manually. How to do automatic scaling also we'll see. Okay. But yeah, you don't need to stop anything or start anything automatically. I mean, it can take care of that.
Okay.
So fine, okay, we are having 2 pods, 2 replicas of the same pod, which is running some image, but could you access it from the server? Could you exit from outside? Like, let's say maybe you hit master node or worker node, and can you see that application, like which is supposed to be running on port 80 or whatever? Can we? Yeah. Not it, because we did not expose the application to the external world. So how do you expose this application to the external world? How can we do that?
With kubeproxy.
Kubeproxy will take care of networking, but like firstly, how do you expose your application?
Maybe port forwarding.
Let's see. See, this is your pod. Okay, this is another pod. Every pod is having some IP address. Okay, the IP1, let's say this is having some IP address IP2. Now let's suppose I'll take this pod 2. Okay, I'll forward this IP to the host, right? This is the host machine, means some worker node or whatever. So I'll forward it to some port, and if I access it, yes, I can do it. But what if this pod is gone? Pods are not permanent, right? This pod may be crashed or gone or deleted, or else you might have multiple worker nodes. It might be going to some other worker node. So this will not work then, right? So, okay, later I'll depend on this. I'll forward this pod. Again, this may be moving, right? Pods are not permanent. They are ephemeral. Means you can't depend on the pods, right? They will be created, they'll be running, they may be destroyed, they may be crashed, anything may happen. So you cannot depend on individual pod IPs to do port forwarding. Then how can we achieve it? There comes the next Kubernetes object, which is called service object. Like you create deployment object, pod object, you create another service object. Service object will have stable DNS and stable a virtual IP, which are fixed. Stable in the sense which are fixed, which doesn't change. And I will tell this service object to go and attach. This service object should go and attach to all the pods. Which pods? There might be so many pods. Right now I'm having only one deployment, right? Right. I'm having deployment which is running some Nginx. I may have another deployment which is Tomcat, whatever. So how do you tell your service to attach which pods, which deployments? I'll tell the service object to search for all the pods with this label. So how many pods are there on your cluster right now with this label?
Oh,
2. So this service object will search for all the pods with this label and get attached. Means indirectly, I'm attaching this service to the deployment. Correct? App v1 means they're all present in deployment. It goes attached to this deployment. Right? So what is the benefit of it? Here also pods will die. Yes, pod will die. This pod may be gone, crashed. Okay, another pod may be coming up on another worker node. But they're all replicas, means always this label is same. So service object will go and attach to this one. Service object will always keep on searching with the pods with this label. You have to configure it. How does this know which label it should attach? We will configure it. We will write a manifest file and tell the service object to go and attach to the pods with this label. So a pod may die or come up. So this service object will always go and attach to the pod with that label. Means always it's attaching with all the pods which are in this deployment one. So what happens? Service object will give you an IP. Now I will hit the node, means any worker node IP in the cluster with some virtual port which service object will give. Okay, this is the URL. Consider this is the URL. Now, any requests coming to this URL will be served by these pod replicas, 2 replicas. Means these pods will stay in a queue, always fighting with one another to serve the request coming to this URL. Always the healthiest pod will be serving the request at any given point of time. Making sense or confusing? See, you should learn with a great clarity. That is the key. You should learn it properly with clarity and practice. These 3 things are important. So if you have any question or confusion here, you can ask me. But please don't deviate from the topic. Anything else you have, we will discuss at the end or at appropriate time. This concept, related to the concept, first put your queries. Is this clear?
that node IP part, can you please explain, Preeti, again?
Worker nodes, you have worker nodes, right? Those nodes IPs, IP
Okay.
address of those worker
Means-
nodes, like how you access in the Docker host.
Okay, so
Your
whatever we have
worker node
given
IP.
insider that IPs.
Insider that IP means? IP
Uh,
address of the worker node, IP address of your master node. These are the IP address, right? IP address of your master node, IP address of your worker node.
Okay.
See, always in Kubernetes, node means worker node. But of course, here in our type of cluster, it could be must node also.
Okay.
Node means generally in a cluster, like I told you, worker nodes are called as minions long back. Now they are called as worker nodes or simply Kubernetes nodes. Kubernetes nodes means generally worker nodes only. So here we are not depending on any pod IP. Pod IP will change, but the configurations, the template will not change. So
Yes,
that's
got
a
it.
service object. Yes.
Preeti, here that if you have a two worker nodes, so which worker node IP we need to give?
Any worker node. Any worker node.
Okay, and we can compare anything here with network load balancer like virtual IP.
Just understand this is a service object of Kubernetes. Okay, the load balancer you are talking about is a different concept. But in this service, again, you have different type of services like load balancer. We'll go through that one by one.
Okay.
Yeah, I mean, here you are talking about load balancing. Yes.
Yeah.
Here, yeah, your pods are here. Load is balanced across the pods in the cluster, right? But I don't want to mention that load balancing because it has different name, different meaning in this cluster. Here you can say load is balanced across the pods in the cluster. Load means requests. Requests are coming. Those requests will be balanced across whatever pods available, like P1, P2 right now. Shall we create the object now? Let's create a service object. Again, I am saying people worry a lot. There is a lot of coding, so much of manifest files I should write. Have we written a single line of code? So
No.
you tell people if still anyone having questions like you should write a lot of code in Kubernetes, manifest files are difficult to write. It's not so. See here you have a service. This is another service manifest file. Sorry, this is pod manifest file. This is, you can also write it in a single file. Pod object, everything separated with 3 hyphens. Okay, I'm taking this part. Service manifest file. See, if you have time, you can read it. But as a beginner, it might be a bit complex for you. But everything will be defined in here. As you go by, you can do this practice of going through it. Not all of them at one go. Slowly, you can get used to it. Okay, you can put any name to your service. I mean, yeah, to your manifest file. I'll put the name as service1. Let this come up. I'm creating another manifest file. Service1.yml. Right, if you want, you can change here itself. The name I would like to give as service1. Select R. This is very important. See, name of the label, it's app label, right? That's what I have given to my pods. And the value is app v1. Name of the port, if you want, you can give any port name or else you can ignore it. TCP protocol, the default protocol as it runs in the browser, port is 80. And here few changes I would like to make. I'll tell you this. Node port first. Node port is nothing but this port means container port. Okay, container port will be forwarded to some port on your worker node. So that's called node port, and this port ranges from 30,000 to 32,767. This ranges from 30,000 to 32,767. So within that range, you can give anything. If you don't mention also, no problem. What it will do, it will take its own random port. But I would like to give as 32,001. Is the number correct? No. Correct?
1010. Yeah, it's correct now.
Okay, then you can add one more thing like type of service. If you don't mention this type, it will create default cluster IP service. What is that also we'll see. First, let's go with this NodePort type of service. You will get this also in the manifest here. You have to search it properly, like NodePort service. Blindly, you can't do anything. You know the concept, you know there is NodePort service. So if you search with it, you can get all of that. Services. Sorry, service types, NodePort, ClusterIP. I want the manifest file for NodePort. Here it is. Okay. So yeah, this is the one I want. So see here, service name is service one. Select R. This is very important. Means service should select the pods with what label? With this label. Okay, name is this. Protocol, container port, the node port which to which it has to forward. Type is node port. If you don't mention the type, by default it will create a cluster IP service. What is that service? We'll do. We'll see. First, let us run this. Shall I apply this manifest file?
Yes.
So apply -f service one. Some error, unknown field type. Let's go here. I think the yeah. See, under specifications, it's nested inside specifications, and it should be at the same level as selector and ports. You can refer the official documentation and apply properly. Yes, it says it's created. Get SVC. See, this is the one. This is the default one available. Leave this, and this is the one. Node port, which is forward to 32,001. Meaning, let me hit this worker node. On which port? 32,001. But you should open that port, right? So, inbound rules. That is a simple image I have, right? But how do you know whether it is attached to the pod or not? One way is describe any object in Kubernetes. Describe type is service, name is service one. See, endpoints. Which IPs? Which IPs are this?
These are the pod IPs.
Exactly, those are the pod IPs. So it got attached to those pods. Minus a wide. See, 71, 72 pods. If you want, you can also check simply like this. Get EP. Get EP means get endpoints. See, service one endpoints are these two pods, which is perfect. And what label it has attached? This label. If you scale also, no problem. If you scale down or scale up, no problem. Service will still remain the same. Let's say I make it 4. Okay. Let's apply the change. kubectl apply -f deploy 1.yml. You don't need to tell the service object separately to go and attach to other pods also. Then how come it gets attached? See? Because they were also having the same label. That's what is that's how service object works. See? One more, 4. Interesting, isn't it? It's not at all difficult. Is it difficult? Are you feeling any difficulty here in Kubernetes? 3.
One query,
Tell me.
we created second file, right? svc.yaml. So is it possible to write a entire code in same file?
You can. Sometime back I have shown you, right? You can separate it with the 3 hyphens.
Okay. Means all services we can give in single file with the
See,
separator.
pod object, service object. Anything you can put everything in single file separated with 3 hyphens. But when
Okay.
you apply, it becomes difficult, right? Which one you want and all.
Okay.
Understood this, everyone? It got attached to 4. If it is 5 or 10, whatever it will attach. You don't need to go again to service object and tell or do anything. No. Your pod may be on worker 1 or worker 2 label the same deployment object, right? So this is important. This is the catch here. Very, very important. This is important. Sometimes what happens in the interview also, this might be the questions like scenario based, like, okay, you have created deployment object, you have created a service object, deployment is showing all the pods are running, everything is fine. Service object is saying a service is created, port forwarding happened, everything is fine. But still you don't say anything here. How do you find out what you have to check first? What do you have to check first?
The labels, which label we have attached.
You have to check the endpoints, whether the service is attached to the correct deployment, correct pods, label is correct or not. Label might be also there, but this might be label of something else. Some other deployment, there might be 10 or hundreds of deployments. It's not one deployment. It might be the label of something else. When you see endpoints also will be there. But you are not seeing here because it might not be exposing anything, or else it might be not a web-based one. Right, if you see here something else, you may identify easily, but you are not seeing anything because that particular pod may not be exposing anything, may not be having anything on the browser to show, right? So you have to first verify the label of your pods, label of the deployment, make sure the selector label is correct, make sure they were all attached properly. Means you have to describe the service. Still, if you want to confirm, you have to check the endpoints of the service. You have to describe the deployment object.
Pretty.
Describe, deploy. Yes, please. Deploy one. Tell me.
Yeah. So first you had created three deploy objects, and after that you removed. So that there I noticed the IP address was 71, 72, 73. Then you removed. Then you
Mm,
again scaled. Now it
mm,
is 74, 75.
mm.
So that 73 IP is not anymore available when you
How
scale.
are we bothered about these IPs? That's why pod IPs are not permanent. We should not bother about it. That's why we have service object. How
Okay,
are we bothered? It might not be released or whatever. We are not bothered about those IPs.
okay, okay.
Your IPs will be assigned within the CIDR range you give. That's all. We have nothing to do with them.
Hmm.
Any more questions? Service object clear for all everyone?
Yes.
Let us do one more thing. Hmm. These are all the pods. Okay, 4 pods are there. Okay, fine. But I don't want all of them. I'm first scaling in just to. Okay, so 2 pods. See, the other one is getting terminated some time back. Now it's clean, so you're seeing 2. So yeah, we are having this deployment. Let's do one thing. Shall we start whether to show you? Okay, we have seen replication, right? Scaling we have seen. We have seen the replica set, like how it's managing the pods. We have seen service. Shall we see rolling update? Yeah. What is meant by rolling update? See. Yeah. See, if you see here, this is the Docker image we were running, right? And in your repository, I mean in your Docker Hub repository, right, you have one more V2. The whole idea here is, if you recollect and remind your pipeline, it is pulling, right, whenever a code change is happening, it's pulling the code, compiling, building a new Docker image, pushing the Docker image each time to the repository, correct? Let's say, okay, compile some test, then it is building the Docker image, right? Every run this is happening. Building the Docker image and pushing the Docker image to some registry, right? Then we are deploying. Of course, I told you we should not deploy every image. You choose the image and deploy it, right? So here I want to deploy the image, actually one version, like every run, so many Docker images would be deployed. And I have deployed version V1. Now I want to upgrade the application, means next version I can deploy, right? That's what is, see, how do you upgrade your application? By running a new Docker image, correct? So I want to change this Docker image. So if that is happening, like generally when you're doing in the traditional approach, there'll be a lot of maintenance work, lot of downtime required, correct? So if that is the case, like how do you upgrade your application? That's called rolling update. Rolling update means how do you upgrade the application without end user seeing any downtime, right? How is that possible? Generally, they go for maintenance state, sometime application will not be accessible and all. But how do you achieve it in Kubernetes? That is another advantage of Kubernetes, right? So let's see how to do that. This is your deployment object. Deploy one. Like we already understood, it's having a replica set, correct? Replica set name will be prefixed with the same deployment object and some suffix like X. Within that, you have the pod replicas. And these pod replicas are coming from V1 Docker image, correct? So this is what is happening. Now I would modify this image and I will apply the change. Then what happens? It will create another replica set in the same deployment object. This is how deployment object helps in rolling updates. It will create another deployment object. You can have two replica sets. Sorry, it will create another replica set. It can have two replica sets. Replica set name will be again prefixed with it, but different suffix. And it will have pods. Here, what happens? Pods will be started here, but with a new Docker image. When a new pod is coming up here, it will terminate the pods from old replica set. But old replica set still will be there. Means pods will be switching to the new replica set with a new Docker image. This is called rolling update. So what happens whenever a pod is coming up, a pod will be going down in the old replica set parallelly, simultaneously. And by the time the new replica set is ready, traffic will be diverted to the new replica set. And theoretically, it offers zero downtime, but practically there might be some downtime. But yes, that's how you can achieve zero downtime here. Got it, everyone?
Yes.
So now let us do this. Let us see this change. This is called rolling update strategy. There were different deployment strategies in Kubernetes. This is called rolling update, the default deployment strategy in Kubernetes, right? Default deployment strategy in Kubernetes. Let's go to this. What I would do, everything label is same, everything is same. So service object should remain same, isn't it? You are changing an image, but this is same. Sorry, whatever image it runs, this would be the same. And now you can apply the change, but before that, describe type and name. If you don't give name, it will describe all the deployment objects. As of now, I have only one deployment object. So this should be fine. kubectl describe. Okay, so see, deployment controller scaled from here to 4 and then to 2. So here you can see the image name. Okay, now I applied the change. Nothing will change except when you describe, you'll see the change. Now you describe, see, everything else would be same, but you will see one more difference. Get replica set, first get deploy. Here you don't see any change. Replica set, you will see the change. See here, old replica set is 69B8, it became 0. New replica set started 16 seconds ago. All the pods got shifted there. See, new replica set pods. Irrespective of what may happen, your service will remain same because it needs only the labels. See, 76 and 77 new pods, it got attached to these new pods because they have the same label and you should see the upgraded version. This is your second Docker image doing. Interesting, isn't it? These are all really interesting concepts. I find it really interesting. Hope you are also feeling the same.
Yes.
Yeah. If you don't follow this properly, right, other tools you can troubleshoot and do somehow fix the issues. Kubernetes, without understanding, you can't blindly troubleshoot and work on it. So you have to learn them properly. All right, so deployment, replica set, pods, endpoints, right? They were all doing good. That's a rolling update, right? You can also see this with the command kubectl rollout status, deployment, and the deployment object name. Says it says successfully rolled out. Can I see what roll happened? Rollout, history, deploy or deployment, whatever it is, anything is fine. See, two versions, right? This is the first one. This is the second one, upgraded one. This is what is called rolling update, default deployment strategy in Kubernetes. What if I want to roll back? Like, let's say this version is not doing good. Client want to just roll back to the previous version. You don't need to change the image again. Then how do you do that?
You can change replica set.
You can just do it with the command rollout history, deployment, rollout history, rollout undo the deployment, rollout, undo, deployment to which revision? There were revisions, right? To revision equal to 1. So it says it's rolled back. You just see the status. It says it's rolled out. And here you don't see any difference when you say get deploy. Replica set will show you the difference. See, pod switch back. Do you notice the difference? See this one and this one. It went back to old replica set which was created 36 minutes back. And also get the pods. Your service will never change. New pods got started into the old replica set. And the service should remain same. But it got attached to the new pods because of the label. And yes. You did not change the YAML file. YAML file is still this one. It's showing this. But how do you know which image it was running? Describe, deployment. Right? This will tell you actually which image it was running. See here, everything you can see. Scaled up, to deployment replica sets, different replica sets. You can see here how it was switching. Slowly, if you analyze, you can see. First, it was in the old replica set. This is all old replica set. Here, new replica set came in. Right? Again, old replica set. They were terminating. If you see, scaling up means in new replica pod starting in new replica set. Say simultaneously, it's going down in the old replica set. Do you notice this difference? Scale up in new replica set, scale down in old replica set, one pod. Again, scale up in new replica set, scale down in old replica set until parallelly it has achieved everything. Can you notice that? If not, go through line by line, you can see that. You can see it better now. Observe this. Parallelly, it's happening, switching. Yeah. So this is the default deployment strategy in Kubernetes. Any questions in this strategy?
No.
So yeah, see, practically zero downtime is not possible because during the switch over, there might be some lag or latency before the new pod picks up the traffic. Okay, practically there might be some downtime seen. So there comes another strategies like blue-green deployment strategies, canary deployments, and so on. We will also look into them. But before we step into those strategies, we have few more things to learn. One is the service types. Okay, we have created a service, which is of type NodePort. Do you see any drawback or limitation with this kind of service? Do you think will it work in reality? What are the problems or what are the limitations you could see with this service? Okay, first thing is NodePort service. As the name says, you hit on the node IPs, okay, and some port number to access the application. Fine. But which node IP and which node IP and the port number URL will you give? Because let's say this is URL 1. I have another worker node IP2, some port number. Port number is same, that's a service port, the service virtual port. So which URL you will share to the end users? Correct? Yep. First problem. Second problem. Here in this type of service, load is balanced across, listen this carefully, balanced across pods in the cluster, but not balanced across nodes in the cluster. What is meant by that? See, we are depending on node IP. Nodes are also not permanent in the cluster, isn't it? Any worker node may crash or it may go for maintenance state. It might be down, new node may be coming up with new IP. Correct? Yeah. If that is the case, like how do you handle this? Like it is not balanced across nodes. So we need a service where we should not depend on the node IP. Correct? That's where comes something called load balancer type of service. Service type is load balancer. Okay, service type itself is called load balancer, meaning here like you have NodePort service, load balancer service, then you will not have NodePort. You will have generally it's called target port. It would be generally the same port as your container port. What is the use of it? It will again selector, everything concept is same, but this load balancer will give you a stable DNS, a fixed DNS, a kind of URL you have, right? It is fixed. It's not dependent on any node IP. So you just hit the URL and exit. Means now load will be balanced across pods and nodes in the cluster. Understood what is a load balancer service type? And this is the one we should use in reality. In real time, this is the service we should use. Okay. So, okay, ours is a bare metal kind of setup, isn't it? Means it's a physical servers. On physical servers, we have created a cluster. It's a called bare metal type of cluster setup. So here, if you want to use this service at the backend, you should install your own load balancer, a physical load balancer. Like what are load balancers? What are the different load balancer services we have? Nginx, HTTPD, these are web servers. Also, they work like load balancers, right? Or else F5 load balancer. So many other load balancer services are there. You have to install this load balancer on a separate server. Do you remember we installed Nginx HTTPD in the beginning on our Linux classes?
Yeah.
Like that, you have to install this as a load balancer service. How to use this as a load balancer service? That's a different subject. You have to configure it. Then you can create this load balancer service, right? Because these services provide you with the DNS and all. Means there is a lot of work you have to do at the back end if you have to use this load balancer service. Understood? So if they are creating clusters on-prem, they will do this. They'll create Nginx or HTTPD or F5 or traffic. There were so many other options, alternatives. So they'll install it and they'll use it as a load balancer. But with our lab setup, we cannot do this. Like you can't just, like it's again an overhead or additional task. So we would not be doing it. We will go with NodePort. But if you want to see this, right, NodePort, I mean load balancer. This the advantage is you can create this load balancer on cloud. When you create it on cloud, means like if you create your cluster with GKE or EKS or AKS, then if you create load balancer, you don't need them. You don't need a separate load balancer. Why? Because cloud means the cloud provider will create its own native load balancer to spin up load balancers at the backend. What I mean is, let me show you. For this kind of on-prem kind of setup or bare metal server type of cluster, you have to set up your own load balancers. If you are using EKS or any managed services on cloud, cloud will use its own load balancer service. See here, it has got its own load balancer service. Whenever you create a Kubernetes service of type load balancer, it will use this load balancer. It will automatically create a load balancer here and it will use it. So you will not have that overhead. So I'll show you load balancer service when we go for EKS. Understood? So for now, we'll go with NodePort. That is the second type of service, load balancer. This is used in real. Only the difference is you will get a DNS, that's all. Okay, we'll see that in EKS cluster. So that is a second type of service. There is another type of service called ClusterIP. That's all. Everything else is same. ClusterIP means if you don't want to expose your application outside, only they have to communicate inside. Means only services should be communicating internally. You don't need to access them from outside. Then you can go with ClusterIP. That's for internal communication. Also, this is very secure type of service. Okay, always we should prefer ClusterIP. Load balancer also will create only the endpoint. I'll talk about that, okay, where you should create load balancer. When we talk about ingress, we'll go into more depth of it. Got it clear, everyone? The three types of services. I'll wait for your response. If it is clear, we'll proceed.
Yeah, it's clear.
Understood, right?
Yeah.
All right. So I'm just putting this back for NodePort because we want to access it from outside from browser for now, and this should be the NodePort. And the port number, whatever you want to configure, I have configured it as 30,001. Right. So yes, I have one deployment, one service.
It was incorrect. Just go back to that file. So 32,000.
Yeah. Okay, thank you. So everything is back. I just want to delete this deployment. I would like to reapply because I don't want any versions, any updates. I'll just recreate it. So deployment, I'll just go with version 1. Okay, everything else is fine. So before creating it, I would like to create parallelly another deployment. Okay, first let me create it. -f deploy 1. Okay, I would like to create one more deployment. I'm copying the same file, name it as deploy2.yml. Okay, deploy2.yml. Here, deploy2. Okay, labels app v2, match labels v2, v2, deploy2. Okay, just starting another deployment. Okay, before applying, I would also have the service object, another service object. Service 2. I just want this to be service 2. App, the label it should select is this, and the port is 30,002. What is this actually? Why are we creating two deployments? See, we have discussed about rolling update strategy, right? And we understood there might be some downtime. To avoid that, there comes another deployment strategy called blue-green deployment strategy. What is this blue-green? See, blue-green means two environments parallelly without interrupting the existing environment or the production. Let's say this is the production one or running one. I don't want to interrupt this. This is having, let's say, deploy one, service one. Okay, I'll start a parallel environment called deploy2 service 2. Deployment will be attached to service 1. Deployment 2 is attached to service 2 with those select tasks because this is having label app v1. This is having label app v2. Okay, so this is how it is. Now what I'll do, I'll just, so now deployment is attached to service 1 and so on. But now I'll not interrupt the production one. Okay, it should be working fine, although no interruptions, no downtime. Rather, I'll start another parallel environment called test environment or green environment or new environment, whatever you call it, right? And once this is working fine, I'll put the production service to deployment. I'll flip this service to this deployment. How to do this flip? What changes we need to make this flip? Yes. How to make this flip? Initially, service 1 is attached to deployment 1. But if you want to make this flip, service 1 should attach to deploy 2. So how to make this flip? Anyone? Which files or which parameters, which attributes we should change?
Madam, in service file, we need to name the deployment 2 name.
In service, yes, come again.
In a service file, we need to change the deployment name.
In service file, deployment name means label name, right? Label name.
Yes.
We don't put deployment name. Label of deploy to. We should change the label of deploy to in the service one, right? That's how you flip. Yeah. So let us see. Let's see how to apply it. First, we are having one deployment. Get deploy. And one service. This got attached to this. Okay, get type and the name. Okay, fine. So here I should see the first service. Good. Now let's create another deployment. Get apply -f deploy to.yml. Right. Also, let's create service 2.yml. Okay, now kubectl get deploy 2 deployments. Within each deployment, there might be replica set. That's different. See, each deployment is having its own replica set. Get pods. Yeah. See, deployment 1, 2 pods. Deployment 2, another 2 pods. Get service. Right? See, you are having 2 services. But which service they got attached? Deployment, replica set, service, pods, get endpoints. Yeah, service 1, 80 and 81. Do you see? This is 80 and 81 deployment 1. Service 2, 82 and 83. Right? Perfect. So on the same node IP, I should hit on which port? 30,002. Open that port, right? We have to open that port, 30,002. This is not secure. NodePort is another reason. One is which node you will provide. Another thing is you are opening, this port will be open across all the nodes in the cluster, which is not good, right? Security wise also, this is not good. But for test and development environments, you can use this NodePort service, but not for production environments. So, okay, fine. This is blue environment, production environment. This is green environment or a test environment. This is working fine. So now I want to flip this service one because service one is production service to this. How to do? Where I should make a change? Yes. Where should we make this change? In the service file, right? Go to service one. Here I will change the label as app p2. Perfect, right? That's all. Anything else? So it goes and attached to pods of deployment too. Yeah. Let us save it. Let us apply. kubectl apply -f service 1.yml. Check the endpoints. See, this also got service 1 also got same endpoints as service 2. Do you see that? Means the same production URL without any downtime, traffic is diverted here. Of course, this is also there. Once production service is working fine, I can remove this test service. Delete service 2. I don't need it. Delete, get type of the object SVC and name of the object SVC. That's all. We don't need this test service anymore, right? This is the production one. I don't need this anymore. It should be gone in few minutes. I have deleted it. Right? That is one thing. I also don't need old deployment, correct? Which deployment should I delete? Which is old deployment? Which one should I delete?
First deployment.
Correct? So perfect now. Only one deployment, which is production one. One service one is a production one. But you have all the traffic flipped in here, routed here. Let me check in the cognitive. Okay, this is the reality. So this is a blue-green deployment. What is the advantage? Because you are maintaining parallel environments, you are not interrupting the existing one, you can assure 100% application up and running. You can assure zero downtime with this strategy. But again, there were few challenges. As you are maintaining parallel environment, always double the resources, right? Which can make your cluster very expensive. That is a challenge you have here. But there might be critical applications which need this application up always, no downtime. Definitely, they can go for blue-green deployment strategy. There might be 1% of downtime always because you can't promise 100% SLA. So there might be some downtime seen. Still, this is the best strategy. Again, because of this expensiveness and all, you have another strategy called canary deployment strategy, where you divert the traffic through increments. How is that possible? We'll see tomorrow. Any questions in this path?
Ma'am, I have some questions.
Yes.
Ma'am, if you are going ahead with different environments like dev and QA, so we need to create the namespace and we need to deploy it, or only cluster only we need to create it separate. How to manage dev and QA environments?
It depends on your design, on how you want to, like it depends on your client's requirement, depends on how you manage the deployments. Multiple environments can be managed in the same cluster with the namespaces, right? Like you can have both dev and production on the same clusters deployed into different namespaces. That way it can be managed, or else you can have separate clusters as well. If you ask me, we are implementing both. For some projects, we are deploying it in the same cluster. Maybe my dev environment is very small. Let's say I just need it for minimal testing. I don't need a separate cluster for it. I'm just managing it as a separate namespace. But for some projects which are very critical, very huge, which has a lot of client requests, where many clients are using it, we are managing a separate cluster for production and dev. And a lot of changes happens in dev every day, a lot of deployments, a lot of testing. We maintain a separate cluster. So it depends on your client, your request, like your application, and so on. It could be done in either ways.
Even it is same case like RDS is connected to one part for the deployment. That RDS can be created separately for dev and QA. That is mandatory, or again it depends on the
RDS. It definitely depends on your application, right? Whether your production and your stage environment are pushing to same RDS, I don't think it will happen. Very rare, because production RDS will be different, right? You don't mess up them as the production
the hardware
database with
configuration, everything will change.
Configurations will definitely change. Environment would be the same. Both may be using the RDS, but the size of the RDS, the CPU, memory of your cluster nodes, all of this differs. Also, if you want to work with RDS, your RDS should be in the same namespace. Sorry, same VPC. I'm sorry. Same VPC of your cluster to connect. Your cluster and the RDS should be in the same VPC. VPC concepts we have not yet covered. We'll cover them in the course. Others, don't worry about it.
Okay, thank you, ma'am.
See, practice till this part. Everything is there in your drive. Okay, go through it and do the hands-on. At least watch the recording. I would insist hands-on is mandatory. But if it is beyond your hands, like if you cannot do it, if you say it's not at all possible with me, at least watch the recording. That's my humble request to everyone, so that the training would be fruitful. Just listening, you can't make anything from it. That's just a reminder from my end. Every one of you know that you are all working professionals, just a reminder from my end. So that is all for today. Okay, all the quiz are available. Like today we have done something, that respective quiz you should complete on the portal. Are you doing it, everyone?
Yes.
Kubernetes. By now you might have completed everything. Before today, it's the second day, you should go for it. Right, regarding services, different type of services, everything here, pod deployment and service for the discussion here. You should definitely go for it. And also maybe some questions in the third part as well. Sorry, this is fifth one. So just go through it. Make sure you're doing it. Okay, that will help you like a revision. All right then. Good day, everyone. See you all tomorrow. Thank you all.